With a modest diameter of 1,475 miles, Pluto is not one of the most impressive celestial bodies in our solar system. This does not mean, however, that the famous dwarf planet does not have some amazing landscape formations that amaze experts and the public alike. In order to take a closer look at the former member of our planetary system, NASA sent the New Horizons space probe into Pluto's realms a few years ago. The unmanned spacecraft didn't reach the Kuiper Belt object until 2015, but the mission produced some stunning high-resolution images of the small celestial object, which we'd like to take a closer look at with you today. Want to join us on our galactic journey to the greatest mysteries of the universe? Then remember to subscribe to our channel and click on the bell to never miss one of our videos again in the future. Feel free to show us you like the content of our posts with a thumbs up. Pluto. It is August 24th, 2006, and Pluto is stripped of its official status as a planet. In the more than 7 decades that had passed since the original discovery of the celestial body, Pluto had been a solid member of our parent planetary system. This changed, however, when the basic concept of planet was redefined. This scientific rethinking was preceded by the discovery of numerous other objects in the Kuiper Belt, some of which were similar in size to Pluto. In order not to launch the number of official planets in our solar system into unmanageable numbers, the new class of the dwarf planet was introduced, in which Pluto is now classified. The celestial body orbits the Sun at an average distance of almost 4 billion miles. Due to its eccentric rotational orbit, the dwarf planet needs 248 years to completely orbit our host star. The immense distance between the Sun and Pluto creates the frosty surface temperatures that prevail on the celestial body. Specifically, the thermometer on Pluto never rises above -360 degrees Fahrenheit. With a size of about 6.8 million square miles, Pluto's surface is roughly the size of the South American continent. The dwarf planet is composed of about 70% rock and 30% water ice. We currently know that Pluto is accompanied by at least 5 natural satellites. The largest and best-known satellite is the moon Charon. The satellite, which was discovered in 1978, has a diameter of about 750 miles. Thus, Charon is more than half the size of Pluto itself. Because of this striking size ratio, it is often referred to as the double system Pluto-Charon. In contrast to the Earth-Moon system, the center of gravity around which the two celestial bodies orbit is not located inside the dwarf planet, but outside Pluto. Stunning images. Thanks to numerous photos taken by New Horizons during its excursion to Pluto, we can now view the surface of the celestial body in greater detail than ever before. The image, which shows the dwarf planet in all its glory, was taken by the spacecraft from a distance of about 22,000 miles. The image was subsequently refined so that we can see it in the natural colors that the human eye would perceive when looking directly at the celestial body. What immediately strikes us in view of this amazing image is the fact that the outside of Pluto is adorned by relatively few, small craters. This circumstance means in reverse that the surface of the dwarf planet must have renewed itself in the course of millennia. The case that Pluto has been largely spared from galactic impacts seems extremely unlikely. Consequently, natural processes must take place again and again on the small celestial body, which ultimately cover over the collision points completely. A comparable resurfacing of meteorite craters takes place, by the way, on our blue home planet. Here it's among other things the inflow of winds, the water cycle, and vegetation, which erase galactic craters from the landscape. It's also noticeable that the surface of Pluto is divided into very bright and extremely dark areas. In fact, the dwarf planet shows the second largest brightness contrast of all known bodies in the solar system. Only on Saturn's moon Iapetus do we find even more pronounced light differences. The Sputnik Plain. The large area of ice on Pluto, called the Sputnik Plain, owes its name to the satellite of the same name, which was the first man-made object to leave the Earth. Since the icy area shows practically no impact points, some experts assume that the lowland formed less than 100 million years ago. Possibly, this geological deformation process continues to this day. At first glance, the appearance of the ice surface resembles a frozen mud landscape. The conspicuous indentations in the subsoil, which we can clearly see on the detailed image, are possibly the result of the influence of winds. Fascinating mountains. Not less interesting than the images of the icy Sputnik lowlands are those showing the icy mountains on the surface of Pluto. The smooth surface of the so-called Sputnik Plain flows into a fascinating mountain range, which in terms of its dimensions, really has nothing to be ashamed of in comparison to our terrestrial mountains. Among the most imposing elevations on Pluto are the Norgay Montes, which rise up almost 11,500 feet, and the Hillary Montes, which extend along the western edge of the Sputnik Plain, in turn towering almost 5,000 feet above their surroundings. In all probability, the formations are not made of conventional rock, but of water ice. At the freezing temperatures that naturally prevail on the dwarf planet, water ice can become as hard as rock. How exactly these amazing ice elevations developed on the small celestial body is still an unsolved mystery for scientists, especially the fact that Pluto is not in the sphere of influence of a more massive celestial object, which could deform the crust of the dwarf planet. This causes big question marks for experts. Detailed surface structures. This high-resolution image of Pluto's natural surface structures shows us what the galactic face of the dwarf planet looks like in detail. At the core of this color-enhanced mosaic image, we can see a landscape strip about 50 miles wide that stretches from the edge of the so-called Badlands to the icy areas of the dwarf planet. Crun macula. On the right edge of this amazing image, we see the dark highlands informally known as Crun macula. What immediately catches our eye while looking at this picture is the dark red coloration of the corresponding area. The experts assume that this coloring is caused by tholin. This is a mixture of organic molecules such as hydrogen, carbon, and nitrogen. This complex compound is said to be particularly abundant on Pluto, and thus gives the dwarf planet its characteristic reddish-brown appearance. Crun macula, meanwhile, towers about 1.5 miles above the rest of the landscape. Particularly striking are the numerous interconnected pits that characterize the area. The corresponding formations have diameters of 5 to 8 miles and reach depths of about 1.5 miles. The atmosphere of the dwarf planet. Pluto has an extremely weak atmosphere. The thin, natural protective shell that surrounds the celestial body is largely composed of nitrogen. The remaining components are carbon monoxide and a small amount of methane. Thanks to information gathered by NASA's New Horizons spacecraft during its mission, we know that Pluto's atmosphere extends about 1,000 miles above the dwarf planet's surface. The carbon monoxide it contains, in turn, has an intrinsic temperature of -364 degrees Fahrenheit. This also corresponds roughly to the temperatures that prevail there on the ground. This is despite the fact that the deepest layers of the natural protective shell are significantly warmer, with a temperature of -292 degrees Fahrenheit. Experts believe that the colder surface temperatures are due to the evaporation of methane, which changes from a solid to a gaseous aggregate state. Pluto's North Pole. When we take a look at Pluto's North Pole, we once again become aware of the geological diversity that prevails on this small celestial body. The northern polar region is crisscrossed by long canyons. The largest of these natural landscape formations has a considerable width of about 47 miles. The canyons near this gaping formation, however, are about 6 miles wide. The canyons at the North Pole of the dwarf planet seem to be much older than the canyon systems we find in other areas of Pluto. Scientists see in the existence of the polar canyons an important proof for an ancient tectonic period on the celestial body. Canyon system. The image of the unmapped canyon system shows the area known as the Tombaugh region. Researchers have not yet been able to decipher the exact origin of these countless indentations on the surface. Many experts believe that these mysterious depressions were created by the interplay of ice intrusion and natural evaporation. Since the area in question has very few impact points, it's reasonable to conclude that it was formed only a short geological time ago. In detail, the individual pits have diameters of hundreds of feet, at the same time extending many feet into the ground. The arrangement of the numerous structures allows the experts to draw important conclusions about the nitrogen exchange between the dwarf planet's surface and the atmosphere. We're interested in your opinion. Was there an image of the dwarf planet that particularly fascinated you? And what are your thoughts on the stunning images of Pluto? We're already looking forward to your comments. Finally, we've linked some more exciting videos for you, which you can access by clicking on one of the thumbnails in the credits. Thanks a lot for watching. Take care, and we'll see you next time.